Hello and welcome to Talking Points. I'm Dave Kelly, Director of Advanced Media Production at Cal State Long Beach. Today we're going to put our heads into the cloud and take a look at the future of artificial intelligence and related technologies. My guest today is Dr. Burkhard Englert. Dr. Englert is the chair of the Computer Engineering and Computer Science Department. Welcome, Burkhard, and thank you for joining us on Talking Points.
Hello, Dave. It's my great pleasure to be back and talk to you again.
Well, as you just mentioned, you were here once before, and when you were here the first time, we talked about artificial intelligence and some of the concerns that we had about information security at the time. But you're back again because this is a fast-developing field, fast-evolving, and there's always a lot to talk about.
Oh yeah, it's sometimes very difficult to keep up, and new things start coming up every day.
Well, to start the conversation today, we should refer to the cloud, which I mentioned in the introduction. The cloud is something we're hearing about a lot these days. We know that Microsoft has cloud services, Amazon has cloud services, IBM, Google, and a number of other companies have these cloud services. But for the sake of definition and so that our audience has a complete understanding of this, what exactly is the cloud and why was it developed?
Well, you know, we used to have businesses that would own their own infrastructure in terms of how they would be able to handle customer requests, customer orders, and so on and so forth. And to do that, they would have to buy computers. And they would have to have their own small data centers that would allow them to store, customer data and so on and so forth. But you know, this is a relatively expensive enterprise because if you want to own your own infrastructure, you need to keep in mind that after maybe 3, 4, 5 years, it becomes outdated, and at that time you need to buy new computers. At the same time, you will also have to probably hire someone to take care of these computers, maintain them, make sure they're in order. You have to worry about security and so on and so forth. So now imagine your business is growing. So after a year or so, suddenly you don't have 200 customers anymore, you have 1,000 customers. Then your computing infrastructure becomes obsolete because it cannot handle 1,000 customers. So you need to upscale. But that will again cost you money, and then you may have to hire additional people. So for the businesses, this is a very difficult problem because they cannot always predict what will happen with the size of their business. So now with cloud services, what they allow you to do is they allow you to say, okay, I'm not going to worry about this anymore. I'm simply outsourcing it to a cloud provider. And then the cloud provider will become responsible for giving me access to my customer data, for protecting my data, for taking care of the hardware so I don't have to buy hardware anymore. Instead, I simply pay a fee to the cloud provider, and that fee ensures me of continued service.
And when we talk about the cloud, we're actually talking about a couple of terms. One of those terms is scalability. And scalability allows you to grow at the rate that's appropriate, but it also allows you to contract if your business needs to contract for some reason or another. But with the cloud, you have what's called a pay-as-you-go service.
Right.
Explain that if you would.
Well, think of another example. Say, for example, you are subscribing with a digital service provider, a cable TV company or something like that. And then, they provide you with certain packages. They say, for example, okay, if you want to have 150 channels, you have to pay this much. If you want to have only access to 50 channels, you pay this much. Same thing with the cloud services. So you say, okay, my customer base has increased, so I need more storage space, I need more computing power. So I call my cloud provider and I say, okay, give me this new needed computing power and give me access to more storage space. And so you can do that on basically overnight, immediately. If you have to take care of it yourself, you need to invest in new machines, and you need to kind of be able to predict that. Otherwise, there's always a lag. You now have all these new customers, but you weren't able yet to upgrade your system. So the new customers may find that your system is very slow, it doesn't respond well, and your business may suffer as a result. With the cloud, this won't happen anymore. You can immediately increase capacity, or you can decrease capacity. It can happen instantaneously.
Well, it's a good thing that you mentioned cable television as an example, because we have a very good example that just happened recently with a company known as Netflix. Netflix recently migrated all of their services over to a cloud service. It's Amazon Web Services. Mm-hmm. And in doing so, they allowed themselves to grow, expand, and contract as needed based on customer demand. And we can think of examples of when a really popular movie is coming out, let's say Star Wars or Jurassic Park, the customer requests for download streams might go up to 10 or 15 million at the same time. Yet 3 or 4 weeks later, once that initial surge sort of tapers off, they might be back down to maybe 1 million at a time. So how would scalability in a case like that be helpful to Netflix?
Well, in that case, Netflix could, for example, say, okay, we know this movie is going to be released on Netflix on next Thursday. So starting on that day, we will need additional capacity. So you call your cloud provider or you send a message to your cloud provider and say, please give us additional capacity, give us additional bandwidth, because we anticipate a lot of customers will want to watch this movie within a week of its release, let's say. And then after maybe 4 weeks, demand will go down. So then again, you can reduce capacity. And so Netflix really only pays whenever it needs additional capacity. And when it doesn't need the additional capacity, it pays less again. So it becomes a very, very flexible model. At the same time, Netflix also doesn't have to worry about the infrastructure, right? It doesn't have to worry about how to manage all this in-house and have the responsibility for doing that. It now can rely on a specialized partner, namely in this case Amazon Web Services, who only focuses on this particular problem. And it's their responsibility and their job to make that happen. So Netflix can really enjoy basically allowing others to worry about this problem of increasing and decreasing capacity, right? Because that's not an easy thing to do. But if you have someone who's really specialized on that, it's much easier to handle than if you have to do it yourself.
And so staying on the Netflix example for a moment, one of the chief executive officers of the company said that the reason why they moved all of their services over to the Amazon Web Services because of the scalability, as you mentioned, but also the fact that it allowed for a better, more comprehensive way to operate business-wise, because they had their own data centers, but there were limitations to those data centers. So rather than just literally taking a forklift and taking that data center process and moving it over to the Amazon cloud, they said we wanted to go with a cloud native approach. What does that mean?
Cloud native basically means that you don't just, like you said, forklift your services from your own servers directly to the cloud as they are, and you leave all the software intact, but you redesign your software so that it's optimized to work in the cloud environment, because the cloud environment essentially wants to allow you to be scalable. So in other words, to adjust very, very quickly to changes in demand. If you use your old software from your data centers, that software is not designed to do that. It's basically only designed to provide services, and it's native to your data center. Now you need to change it, and you need to turn it into something that's basically native to the cloud so that it can respond to these increases and decreases in demand, and is very, very flexible. And so that requires you to go in and change the way it's basically programmed.
Now, some people would say, but wouldn't I be giving up a lot of control over my product if I turn everything over to the cloud? What about security concerns? We know that hackers are out there all the time, 24/7, trying to get into various companies. They've done it to Target retail stores. They've done it to the IRS recently. They did it to Sony Studios. So what about that issue of security and control of data?
Yeah, that's certainly a very valuable and very important concern. Although the focus shifts a little bit when you go to the cloud. You see, if you have a lot of small businesses that all run their own data centers, then some of them may be very well protected, while others, may not be so well protected. And it's very hard for us as a nation to control this type of thing. But if you have small businesses using cloud services to take care of their data needs, then you can basically say it's now the responsibility of the cloud providers to provide adequate protection. And so it's easier to defend one large thing than to defend a lot of small things, especially if you cannot control what a small business is doing. And it's just enough to have one vulnerable spot from where someone can gain access to the system, and that may become a larger problem as time goes by. On the other hand, if you have a cloud service, the cloud service will be attacked, but then you can really focus on the defense of the cloud service. With cloud providers, the bigger concern, I think, and the bigger worry that people have is the insider attack. So what I just talked about were outsider attacks, right? So a hacker comes in from outside and tries to breach the system. In an insider attack, someone who, say, for example, who works for the cloud provider has access or gains access to the data, your data, and then maybe illegally sells it to one of your competitors, for example. That's some concerns that some businesses have. And so that's why cloud providers usually give all kinds of assurances to their customers that this would not happen. And sometimes, you see these declarations that their employees have to go through a background check and so on and so on and so forth. Because I think that's really the biggest concern with cloud service and the biggest worry that people usually have, because they have to entrust their data, their very precious data, to someone, a third party that they don't control, right? And so there is this concern: what will the third party do with this data?
So there's a concern about internal control, as you just mentioned, but the larger picture of protecting your data, if you're a company, from hackers in the outside world, you may be better off with the cloud because they have the expertise, because they are large, they have that scalability of security services that you won't have as an individual company.
Yeah, they can basically have whole divisions just focusing on the security of their services, right? And so they have the power to install very, very strong mechanisms. But if you're a small business, you may not even be aware of, for example, that you need a certificate if you want to set up a secure website, or you may have a certificate that expires and it may become vulnerable. And so, there's all kinds of issues, and then again, you have to hire someone. So it's much more likely that we have holes in a Swiss cheese when we have everybody taking care of their own data services, than if we have a large cloud provider that can, in a centralized manner, handle security of their services.
We just have a minute or so before we go to the break, so in less than a minute, we should talk a little bit about big data and how big data is now using what's called predictive analytics to try to give us information about upcoming trends or upcoming problems that may be occurring, such as a disease outbreak. The CDC is using a lot of algorithms now to predict disease outbreaks. Explain how that works. Again, less than a minute.
Yeah, sure. So imagine you have a flu outbreak and people get sick. Nowadays, when people get sick, very often what they do is they don't first go to the doctor, they first go to the internet. They go to Google or Bing search engine, and they type in a search term such as, for example, flu symptoms. And they want to find out whether, they have the flu or not. And this search basically is recorded on Google servers, because if the search engine was Google. And so now Google can go in and can mine their data and try to find out what are some of the most common search terms that were used, and find out where actually these search terms originated. So where the people located that made these searches. And so, for example, if you see that in the LA area you have a lot of searches for flu, or flu symptoms, you know that very likely there is a problem, that a lot of people feel like they have contracted the flu. And that has been done in the past, and it has been shown that it matches very closely actual outbreaks of disease.
And on that note, we will have to go to the break. And stay with us. When we come back from the break, we'll take an additional look at artificial intelligence and how it will affect all of us in the future. Stay tuned.
Ever heard of the world's most amazing toy? Uber sticks? I mean, check it out. The Eiffel Tower, the Golden Gate Bridge, cars, and robots are all amazing feats created by mechanical engineers. You could become a part of this creative field with a degree from Cal State Long Beach.
Welcome back to Talking Points. I'm Dave Kelly, and my guest today is Dr. Burkhard Englert. Burkhard, before we went to the break, we were talking a little bit about predictive analytics with big data, and we used the example of trying to predict where there might be a flu outbreak occurring. Let's talk about some other aspects of big data and using it for predictive analytics or for recognizing patterns. We know that professional athletes, baseball players, professional golfers, folks that swing a tennis racket, do a lot of analysis behind the scenes of their swing and the swing pattern. And they use some big data applications to determine what is the optimal swing given whatever the sport it may be. Can we utilize this kind of technology and this kind of analysis for other kinds of movement that go beyond athletics?
Oh yeah, there's lots and lots of other possibilities, and new possibilities are discovered every day. Just to give you an example, let's say you're trying to protect a building, and you have cameras that are monitoring the area around the building, for example, an airport terminal. And so the cameras are monitoring the people going in and out of the building. And normally people will follow certain patterns when they enter the building, when they leave the building. So now you could have a computer program that has learned through experience by looking at many images, how people normally act when they enter or leave the building. And the program will automatically be able to detect whether someone behaves in a strange way. And there could be then a human observing the same images, and the computer could alert the human and say, oh, there's someone here that acts kind of strange, so something is unusual here, and flag this. And then the human could take a closer look and could decide whether there is any reason to be alarmed, or to maybe call the police and ask them to talk to this person, or whether this is just someone confused who's going back and forth because they lost their way or something like that.
So essentially what the computer is doing, it's looking to recognize patterns and also to identify irregularities, and then take those patterns and those irregularities and come to some conclusion about what should be reported out.
Right. And usually it's a probabilistic model, which means that, the machine is not going to be 100% sure that this is unusual behavior, because it can only match it to what it has seen before, and it may match what it has seen before maybe to 90%, but there's still a deviation. And so that's where the human then again comes in, where the human has to come in and say, well, I confirm this, it's very likely that this is something unusual, it's worth to call someone. Or I say, well, no, this is just, I see this is an old or an elderly person who just lost their way.
So if we're talking about artificial intelligence in a broader sense, and the use of this pattern recognition and decision-making processes, we know that the self-driving cars are becoming more and more prominent. They're not released on the market yet, but there are a lot of tests going on. What about the self-driving cars, the decisions that will need to be made by the computers that are driving the cars?
Well, yeah, it's basically the same principle. You would feed the software all kinds of different examples of what could happen on the road, different situations, and then you would make the software analyze these patterns that it had seen before, and allow the software then to make decisions based on the patterns that it knows about. So for example, when you make a right turn, right? How does a right turn work? Well, we feed into the software many different examples of right turns, and then the system knows exactly how to make a right turn, or how to make a left turn, how to park the car, and so on and so forth.
So we are then in a situation of releasing control to the computer to make those decisions. What about critical decisions of braking and stopping and avoiding accidents, or taking the lesser of two casualties, if you will, in an accident situation? Could there be some moral dilemmas there?
Oh yeah, there is really a lot of concern about this. So imagine you are in a self-driving car, and the self-driving car, the software in the car is programmed to protect the driver and the passengers in the car. But now you get into a situation where you're on a road where on both sides you have ditches. So in other words, you can't really afford to go off the road because you may get killed, because your car may flip over. But then there is a pedestrian crossing the road. So now the self-driving car will have to decide, what do I do? Do I risk my life or the life of my drivers and go off, or do I just run over the pedestrian because it's too late for me to brake? And so if you imagine that the car is not self-driving and it's the autonomous driver, the driver may say, well, I really don't want to run over this person, so I'm going to brake and I'm trying to go to the side. But now the self-driving car may say, well, it doesn't know about morality, it only knows about its task of protecting the driver and the passengers, and may say, well, in this situation it's more optimal to basically hit this pedestrian than to go off the road, because that may endanger my passengers more than hitting the pedestrian. And then later on, after the accident, what if the person is killed and the people in the car have to live with this decision, right? I mean, it opens a whole moral dilemma that could arise.
So there will be ethical concerns, there will be legal concerns, there will be liability issues. All of those things will be wrapped up into artificial intelligence in the future. And so let's transition now to talk about artificial intelligence and some of the other concerns that have been expressed about its capabilities down the line. Stephen Hawking, Elon Musk, Bill Gates, and a number of other folks that are at that level have expressed concerns about artificial intelligence and the fact that computers and all of these data systems can learn so rapidly that eventually they're going to outpace humans. What about those concerns?
Well, what I just mentioned is basically an example of one such immediate concern. When you think about an artificial intelligence system, it's really programmed to perform optimal, make optimal decisions. So in other words, find the best possible solution for the problem it currently faces. And that is something that is very logical, but it doesn't allow for any kind of emotional, real emotional component. And so there's a danger, or there's a concern that as we go down the line and these machines get more and more powerful, that at some point we may get into more and more situations where artificial intelligence takes care of more and more tasks, where then the intelligence at some point says, well, the human is kind of, I wouldn't say like a nuisance, but it's kind of in the way of making an optimal decision. And it may basically take the human out of the loop, or even worse, harm human beings in the process of taking humans out of the loop.
And so the concern is that artificial intelligence can learn so quickly, can evolve so rapidly, and can take in so much data in such a short period of time that we can't possibly, as humans, hope to stay up with that. And some examples of that include the recent Jeopardy game that was won by the computer called Watson. And the computer Watson was able to absorb the entire Wikipedia database and 2 or 3 other encyclopedias in 3 seconds.
Yes.
And so what chance did Ken Jennings and the other great Jeopardy player, the humans, have against the computer? Of course, the computer won. Another example was AlphaGo. There's a game called Go, an ancient Chinese game. I'm not that familiar with it, but from what I understand, it's the most complicated board game in the world, much more complicated than chess. AlphaGo was the computer that defeated the best human player 3 times in a row. Human came back, finally won game 4, lost game 5. What about that?
Well, I mean, that's a great example of the power of artificial intelligence, and it shows really the sky is the limit and where things can go. On the other hand, it's just a game, so it's still at the stage of really, when you think about a game has clear defined rules. So it's perfect for artificial intelligence because, in a way, you're trying to optimize the next move, and if you have clear defined rules, then that's an easy thing to do. But if you are in more situations where humans are more important, then often you don't have these clearly defined rules, and that's where kind of artificial intelligence struggles, or where artificial intelligence could cause problems by, in a way, making the wrong decision. I think artificial intelligence is great in helping us accomplish tasks where we as humans may get distracted, or it requires us to look at a computer screen for hours and hours and hours, like in the example I gave you about monitoring a building, right? You would have to have someone sit there for 8 hours looking at that screen, and it's going to be very difficult for that person to be focused straight for 8 hours and not really making any mistake and not missing anything. The computer is much better at that. It can look at it really for 8 hours, and it doesn't bother the computer. The computer doesn't get tired. So it's great for these types of things. It's not so great for places where the rules are not so well defined, and that's where these people have expressed some concerns that down the line, computers could kind of, in a way, almost overrule humans.
And they've referred to this as the boiling point. Could artificial intelligence reach that boiling point where it just comes to the conclusion that humankind isn't worth it anymore?
Well, we don't know that yet, and I think that's really, at this point in time, science fiction, and I think their concern is more immediate, given what I try to illustrate with the example about the self-driving car, right? That you get into these kind of moral dilemmas where artificial intelligence takes care of something and it does something that we haven't foreseen, and then we have to live with the consequences, right? And it's better to think about these cases beforehand than to worry about them after the fact, and then it's going to be very difficult to fix these things, right? So, and I think they're trying to raise this issue that straightforward optimization is not always the best way to go. You need to be more flexible, and you need to also find ways of kind of cutting back the AI when it's not appropriate anymore, and basically letting the human again take over. So this is kind of where the challenge lies. How far do you let the artificial intelligence go, and when should humans take over?
There are other folks who look into the future, the visionaries, who say it's also possible that humans will evolve to sort of meet the computers halfway. And biomedical engineering would be a key to this. Manipulation of DNA, some of the other ways of genetic engineering and so forth. Will we in the future, we're talking maybe 50 years down the line, become a different kind of species because we're utilizing some of the applications of technology, nanobot technology and that sort of thing, so that we become smarter, healthier, more able to make decisions of an appropriate level. What do you think about that?
I think so, and I at least hope so. And I think that's the challenge with any technology, right? To find that golden way in the middle where you let the technology help you to accomplish your tasks, to help you to succeed as a species, and avoid the pitfalls of the technology where you become, in a way, the slave of the technology. I think in the medical field, that's really a great example of the successes of technology and, in a way, to some extent, artificial intelligence too, where you can really help people to live longer, to live healthier, to help people with chronic diseases that we weren't able to even deal with maybe 10 years ago, and now we can tackle them, and we can try to make people healthy again, or we can have people walk that weren't able to walk, or we can have people see at least dark and light who were not able to see, and that's all because of technology. And so I think there's a lot of promise there, but again, it's always important to keep in mind that technology by itself is not the goal. Technology is basically a tool to help us succeed as a species, and it doesn't make sense to just develop technology just for technology's sake.
Well, we only have less than a minute left, so let's bring this back down to earth a little bit. If I am just the typical user of a smartphone or a computer at home, real quickly, in 30 seconds or less, how do I protect my data? What's the best way to make sure that my data is as secure as possible?
Well, first of all, you have to make sure you always, when you send anything like a credit card number, you go to websites that encrypt the data as it is transmitted. I mean, nowadays, this should be all websites. Always make sure when you get strange emails, you don't just blindly trust what you see. You make sure you look at the actual email address. Is it really coming from the source it claims to be coming from? So be vigilant, be suspicious, don't trust without questioning.
And on that note, we'll have to bring this program to a conclusion. Thank you for being here today.
Thank you. It was my great pleasure to be here.
And thank you for joining us for this edition of Talking Points. Join us again soon for another episode. Until then, I'm Dave Kelly. Have a nice day.